Happy Friday. Made it through another week. For those of you who are AP testing, hopefully that went well. Hoping for some high scores there so you can get some college credit. Alright, so actually when we're solving for Gibbs energy, which is the notes we took on, it's actually not that bad, but let's take just a step back real quick and go over what endothermic, exothermic, and entropy are. So that way, because these are concepts, and I think that will help kind of drive the calculations that you'll do for Gibbs energy. We're not going to do a deep dive because trust me, if we did deep dive, it'd be a whole different thing. It does get a little complicated, but there's not enough time left in the semester for us to go over it, which is probably a good thing. But let's go over these basic concepts, or foundational concepts, I should say, so that it helps when it comes to calculating for Gibbs energy. So endothermic, what does endothermic mean? Endo, right? This part here, endo means inside. So what does that mean? In terms of heat, if we're talking about heat, that means it's going to be absorbing heat. Okay? So in endothermic reactions or endothermic situations, but typically it's referred to as endothermic reactions or endothermic processes, you have heat absorption or absorb heat. What does that mean? The surroundings, what's around the main thing gets cold. And lastly, delta H is positive. So delta H refers to heat, and it's the change in heat. So let me write that down right here. So if you have something like delta H, just refers to change in heat. And since heat is being absorbed here, it's going to be positive. Okay, so if any of you are in sports and you hurt yourself, you have a bruise, and you use a cold pack, that cold pack is absorbing whatever heat that is coming from wherever you're putting it on. But then, of course, you feel it cold. So in this case, right, the ice pack would be getting warmer, and your knee would be the surrounding, it'd be absorbing the coolness, so it'd be getting cooler. Okay. So we're talking about here, right, when you're sweating, right, because you're absorbing the heat and you're hot, that's why you're sweating here. An ice cube here, if you were to set an ice cube on your table, on your desk, it would be absorbing the heat, that's why it's melting, and that water, your desk would start getting cooler. And then, of course, baking is absorbing the heat. Exothermic is going to be just the opposite. Okay, so exo means exit or outside. Oh, I could do better here. Okay. It's going to be the opposite. So what exit outside, that means that our heat is going to be exiting wherever it is, right? So here it's releasing heat. The surroundings, whatever's around your item of focus, is getting warmer. And delta H is negative. Because heat is being released, the change in heat is going to be negative. You're releasing heat, so that's negative. Think about it as you using up your savings, right? You're subtracting out money from your bank account. Endo is you're working, you're saving up your money, so you're putting it in, so it's positive, it's increasing. So for example, here we have the burning of wood here, right? The wood is burning, it's releasing heat. Hand warmers. If you've ever used a hand warmer, it's a little pack that you break up and it releases heat, right? So it's going to make your hands warm. The surroundings are your hands. So here, whichever one you want to choose, right? Let's do the fire one, so it's the first one. Your surroundings, which is, I'll not do this one. Yeah, which would be you, right? So your hands, they're getting warmer. The hand warmer is getting cooler because it's releasing that heat to your hands. Other examples are like the rusting of iron here, right? So again, it's releasing heat, it's oxidizing. And then here, when something freezes, it kind of sounds a little counterintuitive, but when something freezes like it does here, it's releasing heat, right? Heat is being let go so that this cools down and freezes. And lastly, entropy. Entropy can be described as the, let me move this down. Can be defined as disorder, randomness, or how spread out energy and particles are. Okay, so for example, you have your room, right? It's clean on one side, it's messy on the other side, right? Many of us, depending, right, our room might look like this throughout the week because we have sports, we have different responsibilities we have to take care of. So we're this, and then comes a weekend and your parents are like, all right, you need to get it to this, right? So here where it's clean, the entropy is low entropy, right? Why? Because everything is where it's supposed to be. It's clean, it's organized. On the other hand, over here, it's going to be high entropy. Why? Because everything's all over the place. There's a messiness, right? It's random, it's all spread out. Things are not where they're supposed to be, okay? So these are the three concepts that I want you to understand a little bit, because I realized that I threw them in the notes, but we hadn't gone over them, so we should. They're very basic and easy to understand. And now you'll use this to just do some quick practice. It's a Friday. Let's not do math. We'll just do a little quick practice. Understanding or going over these three concepts, and then we'll do the Gibbs energy formula on Monday and Tuesday. It should be fairly easy. You only have one formula that you had to plug in numbers for, kind of like molarity. And then on Friday, you will have a quiz next Friday. You will be having a quiz on these three topics, so exothermic, endothermic reactions, entropy, and then the Gibbs energy formula that we'll be working on the beginning of next week. All right, I hope you enjoy your weekend. Have a great weekend. We're almost done with the school year.